Hello, this is a short note to illustrate a process that is designed to answer a very simple question regarding ASCAT scatterometer satellite data. And the answer to that is, if I'm sailing in my boat and I'm somewhere in the ocean, somewhere around here, I don't know where, but it's some random place like this, the question is, how many times a day can I expect to get scatterometer data that will be useful to me? But that's very general. That's a little bit too general, because we can use this data in several ways, and sometimes data rather a long distance from us could still be very useful in evaluating some weather maps. So let's be more specific. So the specific question I want to address with this video is, how, at any given place on the Earth, how many times a day can I expect to get scatterometer wind data, satellite winds, within 200 miles of that position? So that's the question. That's actually a question in one of our workbooks, and we have an answer to it. And then today, for the first time, I figured out a way to get a quantitative answer to that. Before, we had to estimate it. Here, and let me back up just 1 second. This scatterometer data, and this is the main page where it's presented online in graphic format. You just Google ASCAT, this will be the top link. And this shows 22 hours of data, some 13 passes or so. And then you just go and you can click a spot here on this map, and that will show you the data. And this color bar is pretty good for figuring out the actual wind speed. So these are the passes. There's one pass. Again, we have a lot of articles on ASCAT, and our textbook, Modern Marine Weather, spends a whole chapter on this very important data. ASCAT data is the truth meter of marine navigation. As soon as we get a weather map or a surface analysis map, then one of the first things we want to do is take a look at the ASCAT data, the satellites that went by, and measure the wind speed to see if that analysis map agrees with the actual winds we see. If they do agree, then we can have confidence in the forecasts based on that analysis. If they do not agree, then we have to use the forecast with the caution. So that's the first step. And so even the issue of even predicting when the next one will occur at a given place, that's another question. That's not the question we're answering now, not how to predict when the next one will come by. The question is, more generally, at any given place, how many times a day do you get this wonderful resource that might be useful? And that's what we want to answer. And I just want to stress that it's not a simple thing to, whoops, I don't know what that is. It's not a simple thing to answer, because it's a sort of complicated business. The satellites go up here, like this is one pass. These two sides together are one pass, and that's an ascending pass. And that goes around the Earth. This satellite goes around the Earth 103 minutes, and 104 minutes is the orbit time. So it goes up the Earth this way, and then it comes, let me see if I can, oh no, I roll. Then it comes back down the other side. So this is an ascending pass. But then then there's several problems. For one is, this takes about 30 minutes to go all the way up and down like this. But the instrument cannot see directly below the satellite itself. It can only take data off to the sides. That's explained several places in our book and others places online. So this one satellite pass has two swaths of data, either one of which could fit into our 200-mile range that we're going to sit on some points here. And so that's one thing. Then you'll see another, and also, of course, the Earth is rotating. That's why it sweeps around the Earth. That's the way the whole thing works, by the way. Here, this is one pass going up. 103 minutes later, it's this pass. 103 minutes later, and so forth like that. And then you also have to, I'm sorry, I don't mean to click that, I mean to just roll it. And then you have the thing coming back down the other side. And it's tilted like this because as this is in a polar orbit, it's a polar orbit, the satellite's just doing like my little hand here, satellite's doing this, but the Earth is rotating this way, so the track below it is actually moving this way on ascending pass, and then the other way on a descending. So it's not a trivial matter to figure out how many times a day will any particular place, like here, whatever, will see data. But we now have a very nice way to answer that. So let me go about showing that. And the tool we're going to use is LuckGrib. LuckGrib has a several. I'll put a link to these various things, software tools. LuckGrib can download the ASCAT data as GRIB files. So let me, which makes it takes a sting out of it. But let me go back to how I realized the easy way to do this is. Well, I don't know particularly easy, but let me pause a minute. I just realized a picture I'm going to need. Well, no, I know where to get it. Okay, I know where to get it. So here's the sort of the trick. So we go to OpenCPN and we pick 6 random places. This is obviously going to be depending on latitude. We'll see that in a minute. So we've got 3 here and 3 here at different latitudes. And then I just randomly pick a point. I drop a mark. You go in here. You go to Properties. And then you go up here. And I'm just going to say put 1 range ring and make this 200 nautical miles. Right? Like that. Okay. So there. And then I zoom in on this thing. And then just make a route like this. Route. Well, I'm not being very careful here. Okay, escape, something like that. So that's the way I made these 6 things like this. Now then, you can then go, this we don't need, delete. I made a route. I got to delete that, delete. Okay. No, I don't want, wait. Well, okay, that the guy doesn't matter. Let's leave him right there. Okay, so then when you go in here into your routes, you'll see these routes that were made here, and then you can just export these. You see, you can highlight them just like that, and then export selected, and you export them as a GPX file. Okay, so that's the use of OpenCPN. It was just a very convenient way to mark out the territory we're going to watch in this program. Then, besides being able to download the GRIB files, which is very valuable, then here we can import, let's see, file. Oh, I don't know if you see this, but import GPX. So I can import these routes and then display them here. So there we are. Then the next step is we just go and download. So I would show some picture of the Earth like this. The default is take whatever you've got in there. And then I would just go get get a new request. And then this is under the research category. There's a tremendous amount of data in LuckGrib, and that's ASCAT, and the parameters are just you can get a flag if a rain destroys the data, and then you get that, and you just say, and there's no real choices here. You just there's no choices. It's going to pick this window and it's going to download them. Then I'm going to cancel that. I'm not going to download because I've already got the data in here I want to look at. But what it does is it then goes online and grabs for you the last 3 days of data passes that occurred within the window that you've selected. And I have that data. It must be like from here to somewhere over here that I selected. And it downloads it. Then those passes are marked on the bottom here. Each one of these is one of the data passes. And so then we're ready to go. Let me just move through this and show you, see what's happening here. There's the pass. There's the pass moving that direction like that, and now it'll come in the other side. And then pretty soon you'll see ascending, then you'll see the descending, and so forth. Yeah, there's the descending. All right, so that's what we've done. And then here is the start, and the start is right here. So look, at the first pass on this day, which was September 5th, there's only one guy got any data, this guy right here. But he got data right in here, and you can see it. And then if I look in the top right up here, I'll see what time it is. And that was like 0028. So that's a time. And so that would be recorded as a one incidence on the 5th. Then I go up here and click again. Nobody in that pass, nobody there, nobody there. And then I just keep stepping through here. That's the process. And what do we have here? Okay, so here now we have one. So this is not close enough to count, but here's a data pass 0649. So Central Pacific 0649. So I put a check mark right down on a sheet of paper. That's one. And then I keep going. And then I just watch all of the ocean here and add them all up and just step through here. There's about 50 passes here and 50 the next day. So we have 6 positions done twice. Now, let me come over, see if I can find this picture. Yeah. If I come over here now is where I've just summarized all this data in this article. I'll put a link to this article, which is a little slower presentation of what I'm just talking about. And then there we have the answers. And clearly, the higher your latitude, the more passes you will see, because the Earth is not rotating very fast in miles per hour up near the equator. In fact, you could walk as fast the opposite direction at very high at the pole, but down at the equator it's going the fastest, and so it stays over a given data swath of however miles wide they are longer. So what you see here is at higher latitudes you're getting something like 5, 3. It's like 5 plus or minus 2 up here at high latitude, 60 degrees. In the central latitudes, what we're getting 2, 4, 3 or 4 times there, and then down here at near the equator it's less, 2 or 3 times. So that's the answer. The other thing to keep in mind here is if 2 of these, like 649 and 714, these two, since they're within an hour and within 104 minutes, then these are actually the two sides of the nadir gap. So it's the same pass. So the question is, are you counting passes or are you counting new data? These are actually new incidences of data, but it's 2 different times. And then I'll put a link to this article, but here's our punchline, the answer. In mid-latitudes, and this is global, this is ASCAT data. How often someone's going to ask you, or in our workbook, if you use our marine weather workbook, you're going to get a question like this, 4.14 is a question. For mid-latitudes, you expect 3 or 4 times a day to get data within 200 nautical miles of your position. Near the equator, 2 to 3 times. And at higher latitudes, it's anywhere from 5, 7 times. So there's the answer, and that is our proposed method that anyone can then actually go and test this. Before we just made that statement and didn't have any way to prove it very nicely.